In the year 2021, a curious piece of news emerged. China was developing something in the middle of the Gobi Desert. Surprising, right? Well, not entirely. This kind of news appears quite frequently. Upon further investigation, it was revealed that what was being built there was a nuclear plant, something not particularly unusual, given that such infrastructure is quite common in the Asian country. But if we dig deeper, we find something more interesting. China has discovered an innovative application for a metal it extracts in colossal volumes. It's such a revolutionary use that it could be considered transformative. Stay ahead of the curve with the latest in tech. Subscribe to Data Dollar now and never miss an update on the innovations that are shaping the future of business and technology. Join our community. As always, it is essential to keep an eye on the ambitious projects driven by major powers. Nowadays, many new chemical elements are named after the places where they were discovered, or the scientists who identified them. However, in the year 1828, the Swedish chemist Jöns Berzelius named thorium in honor of Thor, the god of thunder in Norse mythology. Today, we'll talk about thorium, a metal that is not easy to locate on the periodic table and whose atomic number is 90. It is a radioactive element, although its level of radioactivity is so low that it poses no risk. Thorium-232, the naturally occurring form, decays very slowly. To better understand its decay rate, it is important to know that thorium-232 is believed to have originated even before the formation of our planet. While that's already astonishing, the truly shocking fact is that it may have formed before the solar system existed, and possibly during or just after the Big Bang. This means it has been decaying for billions of years, and its radioactivity is extremely weak. Therefore, it's not something we need to worry about. Interestingly, thorium can even be found in beach sand without posing any danger, since its concentration is extremely low. A good example is monazite sand, which may contain between 3.5% and 10% thorium-232. In general, monazite, whether in sandy or rocky form, is the primary source of thorium used by humanity. And how much thorium is there on the planet? It's not exactly a scarce element. In the Earth's upper layers, thorium content reaches 10.5 parts per million. For comparison, tin barely reaches 2.3 parts per million, and arsenic stays at 1.8. Globally, India leads the ranking with the largest reserves. According to several reports, about 340,000 tons are found there, especially in coastal areas rich in monazite. China also has abundant reserves, with approximately 280,000 confirmed tons. However, no monazite beaches have been developed in China, so these deposits remain mostly hidden. This is not a problem for China. Thorium is not extracted directly. It appears as a byproduct in the processing of rare earth metals, a sector in which China dominates globally. In 2023, the Asian country was responsible for 70% of production and 90% of processing of these metals. Nearly all this mining is concentrated in one place, the Bayan Obo mine, located in Inner Mongolia, about 150 kilometers northwest of Baotou. This mine spans 48 square kilometers and holds about 80% of China's rare earth reserves. The main mineral extracted there is monazite, which generates waste after processing. But now it's known that this waste also contains thorium. Given the volume of rare earth exploitation in China, a large amount of thorium is being obtained as a byproduct, along with other essential elements for producing batteries and modern technological devices. This is a significant advantage. Thorium is used in alloys with magnesium and aluminum to increase their strength and heat resistance, as well as with tungsten, which has multiple industrial and scientific applications. However, all of this pales in comparison to thorium's most promising use, nuclear energy. The first experiments in this field date back to the mid-20th century, when the United States, through the Oak Ridge National Laboratory, developed a reactor prototype using uranium-233 as fuel. So what does this have to do with thorium? While most current reactors run on uranium-235, thorium-232 cannot start a chain reaction on its own. But if bombarded with neutrons, it turns into uranium-233, which can undergo fission and generate heat, which is then converted into electricity. At Oak Ridge, under the direction of Alvin Weinberg, an experimental reactor was built that operated for about 15,000 hours between 1965 and 1969, producing less than 8 megawatts. This reactor did not use conventional solid fuel, but rather a mixture of molten salts and fluorides, in this case with thorium. It was a remarkable innovation at the time. However, it faced a major obstacle. No materials existed that could withstand the high temperatures and corrosion caused by radioactive fusion. For this reason, the United States decided to focus on uranium reactors and abandoned the project. In the year 2021, China once again surprised the world by building a molten salt thorium reactor in the Gobi Desert, about 120 kilometers northwest of the city of Wuwei. This reactor managed to sustain nuclear fission for the first time since the Oak Ridge experiments. It has a thermal capacity of 2 megawatts, and although it does not yet generate electricity, it is expected to do so soon. China is already planning a second similar facility with a higher thermal capacity of 60 megawatts and an electrical capacity of 10 megawatts. This clearly shows that the project is advancing successfully. Thorium can be recycled from waste, making it an attractive option for energy production. But why choose thorium if conventional uranium plants can be built? The main reason is that China fears running out of enough uranium to power its growing network of nuclear plants, which already produce about 400 terawatt-hours annually. Although this accounts for only 5% of the national electricity total, China will not stop building new plants. Between 2005 and 2020, nuclear capacity increased by 3.4 gigawatts annually, and this figure is expected to rise to 9 gigawatts per year between 2020 and 2030. Thorium, in addition to being 3 times more abundant than uranium, could meet China's energy needs for 20,000 years. And that's not all. Thorium use can lead to zero emissions. Although China invests heavily in hydroelectric, solar, and wind energy, nuclear remains a key component. Thorium reactors are more efficient, require less space, and generate significantly less dangerous waste, such as plutonium. Using molten salts, waste is reduced even further, making the fuel cycle safer and less problematic. Moreover, since solid fuel is not required, these reactors are safer in emergencies and can prevent hydrogen explosions like those at Fukushima. They can also be more compact and portable. This has led China to consider exporting small thorium reactors or using them in ships. In early 2024, it was reported that the Yangzijiang shipyard planned to build the Kun-24 AP container ship, equipped with a thorium reactor that would not require refueling during its 25-year lifespan. Although this technology is still in development, China has overcome several key challenges and is already planning expansion. Everything indicates that this innovation could transform the future of nuclear energy on a global scale. China has once again demonstrated its ability to lead with more sustainable and safer solutions, betting on cleaner and more efficient energy. However, technical and economic challenges remain before this technology can be adopted on a large scale. The big question is, will thorium be the solution to future energy dilemmas? Or must we still search for more revolutionary alternatives? Will the world be ready to adopt this technology? Or will doubts about its large-scale viability prevail? The truth is that the future of thorium-based nuclear energy will depend on our ability to manage both its risks and its promises. In this context, thorium emerges as a key component in China's energy strategy. Its ability to generate clean energy with less hazardous waste and remarkable efficiency makes it an attractive alternative to uranium. The combination of its abundance, operational safety, and potential to support a growing energy demand has led Chinese scientists and engineers to decisively embrace this technology. This is not just a technical solution, but a strategic move at a time when global energy and technological competition is more intense than ever. Still, there are important barriers to overcome. The industrial infrastructure needed to scale thorium reactors is still under development, and initial implementation costs remain high. Added to this is the lack of a clear international regulatory framework, which hampers global adoption. China, however, seems determined to move forward, seeing these challenges as an opportunity to lead a new phase of nuclear energy, more efficient, safer, and with lower environmental impact. The construction of thorium reactors could also represent a profound shift in how the world conceives the production and use of nuclear energy. While many countries still rely on technologies developed decades ago, China is betting on an innovative path that not only addresses its internal needs, but also aims to set the course for other nations. If these reactors manage to prove their technical and economic viability on a large scale, they could become a concrete alternative for countries that want to reduce emissions without giving up a stable energy source. At the same time, the decision to incorporate thorium reactors into applications such as maritime transport adds another dimension to this technology's potential. The ability to operate ships for decades without needing fossil fuel refueling is not only a leap in efficiency, but also a major step toward decarbonizing global trade. If this model takes hold, China could end up leading an energy transformation, both on land and across the world's oceans. If you enjoyed the video and would like to continue learning about technology and markets, subscribe to Data Dollar and leave a like. See you next time.